This is project 7. We're going to download GPS from the Raspberry Pi using a USB GPS module. So the requirements for this are we're going to connect the GPS to the Raspberry Pi mounted on our quadcopter. We're going to capture GPS as the quadcopter flies, and then we'll download this via Wi-Fi to our host and display the GPS on our host. Because of the circumstances right now, I live in a no-fly zone, so I'm not actually going to be getting this GPS as the quadcopter flies. I'll just have it sitting on my porch. What we need is the quadcopter, which we've already built. We need a USB GPS unit. We need our Raspberry Pi with Raspbian installed as we did in Project 6. Then we need a portable charger, a USB to USB-C cable, a USB-C power adapter, and our laptop. This was a pretty easy one. We just need to plug the GPS into the Pi and fasten it to the Pi. As you can see in this picture, I've got my GPS sitting up here. It's attached to my Pi. And the Pi is set up exactly the same as Project 6. For software, we want to set up our Pi the same as Project 6. Then we want to VNC into the Pi and install PuTTY. I also read that we need to make sure the dial-out group is something we have access to on the Pi. You can just run groups. I'll show you that right now. I'm already in my Pi, and when I run groups, you can see, I'm going to close this other window so it's a little more clear which one I'm working in. But you can see that dial-out is one of my groups. And the easy way to install that is just sudo apt-get install Arduino, and then that gives you the dial-out group if you don't already have it. The next thing to do is to check the port that the GPS uses. So if the GPS is plugged into your Pi, before you plug it in, check which devices you have by running /dev/tty*, and then plug it in, run it again, and see which device is the new entry. So mine is /dev/tty*-acm0, and that seems to be pretty common based on what I've seen on the internet. And then the next thing you need to do is make sure the port is set to the correct baud rate. I'm actually going to make a change here because you need to be suitable for this. So we want to set the baud rate as 9600. Since I have a Raspberry Pi 4, I believe, I needed to change this a little bit from the directions in the PDF. So I'm just going to verify that the connection is working, and I'll show you this live. So I'm going to open up PuTTY, and then we'll make a connection to that port, ACM0, and I'll open up a connection. And now what we're seeing here is live GPS data streaming in. So this is great, but that's not a really great way to look at it. So we'll close that session. And now we want to be able to use GPSD to look at the data. So we've verified with PuTTY, we know everything's working, and now we want to install actual GPS viewing software. So you're going to need GPSD, GPSD clients, and Python GPS. And then since this starts running by default, you'll want to stop everything. And then the command we want to run here, and I've already got it up in this window, is sudo GPSD, both of these ends, our device, GPS sock, and then the important part here is this TACG, which is going to allow us to connect to GPSD from Python on our laptop. So once we run that, sometimes there are errors, sometimes nothing, but then we want to open up another terminal, and we can verify that this connection worked by doing GPSmon or CGPS or anything like that. So now we see live lat and long data for my area. So that's all working well. The next thing, you would verify that in Google Maps, but I won't tell you where I live. I'll unblock this when I turn in the project. The final thing to do is send GPS data to the host laptop. So I'm going to do this with some code that Robert Lucan helped with. And I have this GPS read file here. Pretty straightforward. GPSD is listening at port 2947. This is the IP of my Raspberry Pi. So those are things that you'll need to change when you run it yourself. But basically all we're going to do is we're going to open up a session here, and then we're going to listen for this session data, and we're going to print out the latitude and longitude. I had to pip install the GPS module, but other than that, it's really straightforward, and you can see when I run this Python file, now we start getting GPS data, lat and longs popping up in the terminal. So that's running on the host laptop. And that's all for this project.